you have a cell is connected to an ideal voltmeter, a switch S, and a resistor R. The resistance of R is 4 ohm. The question here, when S is open, the reading in voltmeter is a 12 volt, and when S is closed, the reading in voltmeter reads 8, and when S is open, the reading for voltmeter is 12. That means the electromotive force of the cell will be 12 volt. Because it will not count the voltage drop in the out resistance R. Double I, deduce the internal resistance in the voltage. Once you close the circuit and you here you will have external resistance and internal resistance in the current, the voltage will drop. The value of the dropping in voltage, it will be 8 volts. So if I'm going to use Ohm's law, the total voltage will equal I times R. I, voltage is 8. I, we don't have it. R is 4 ohm. So divide both sides by 4. I, the current, will equal 8 divided by 4, it will give me 2 amp. I need to find the internal resistance. So the internal resistance, the total voltage will equal the voltage drop in the internal resistance plus the voltage drop in R, the external resistance. Total voltage is 12. The total current is 2. We don't have the value of R. We need to find it out. Plus I times R is 8. The voltage across the external resistance. Take this to the other side. So you will have 2R equals 12 minus 8 to give me 4. Divide both sides by 2. So it will give me 4 over 2. The internal resistance is 2 ohm. 2 ohm. Okay. The voltmeter is used in another circuit that contains 2 secondary cells. Cell A has electromotive force 10 volt and internal resistance 1 ohm. Cell B has an electromotive force of 4 volt and internal resistance 2 ohm. Calculate the reading on the voltmeter. I need to find the value of the voltage here that this voltmeter will read. So I'm going to use Kirchhoff's law. We know if our loop, I'm going to first, the current, since there is no current being drawn with the circuit, we can draw the current that comes out from this cell. It will go all the way, they will have the same current. This is the direction of current. Okay, so I will have the same current because all of them, all the circuit, they're connected in series. Now I'm going to assume the current, the direction of, this is the current in the branch, current in the loop itself. Okay, now if our loop goes in the same direction of the branch current that we're going to assign, current in the loop in this direction. If this, we call it the branch current, and this current, the loop current. If both of them are moving in the same direction, and this we studied in Kirchhoff's law, just let me remind you of it, these formulas. Okay, if the direction of the current in the loop, in the traveling current, the same direction as the current in the branch, that means the voltage across the resistance will be negative. So here, same direction, I have negative voltage across the resistance. If they're traveling in the opposite direction, that means the voltage will be what? Will be positive across the resistance. Positive. Now, if the direction of the current goes from negative to positive terminal of the battery, that means I will have a positive electromotive force. If it goes to the negative terminal of the battery, that means I will have negative electromotive force. Let's go back to our question. Here, same current goes in the same direction of the current of the branch in the internal resistance. So I will have here summation of the voltage will equal 0 minus I times 1. Now the current goes to the positive side of the battery. So it will be positive 10, the voltage of the battery. Now we'll continue. The loop current is in the same direction of the branch current. It goes to the negative side of the battery. So it will be negative 4. And then the blue current and the red current, they go in the same direction. That means I have negative the resistance to times the value of the current I. This will equal 0. To simplify, we're going to combine like terms, negative 1 and negative 2. So I will have negative 3I. 10 minus 4 plus 6, this will equal 0. So the value of the current, take this to the other side. So negative 3I will equal negative 6. Divide both sides by negative 3. By negative 3. By negative 3 both sides. I will have I, the current will equal 2 amps. So what will be the reading of the voltage? It will be 8 because 8 minus 8 should give you 0. 4 times 2, the voltage drop here is 8 volt. And the voltage drop here, the current is 2 times 1, it will be 2 volt. So the voltage in the reading across this one will be 8 volt. I times 10 minus 2, here I have 10 volt, minus 2, it will give me 8. 10 minus 2 times 1 will give me 8 volt. 8 volt. The voltage drop in the internal resistance of the battery is 1 times the current I to 1 times 2, 2. So 10 minus 2, it will give me 8 volt. So the reading of the voltmeter is 8. Now next questions you outline there, so you can search them. I'll just go through them quickly. Outline why the electricity is a secondary energy source because it's generated from primary source. Double I, some fuel, this is from topic 8. Some fuel sources are renewable. Outline what is meant by renewable. It can be replaced faster than the rate at which it's consumed, like we have biofuel, hydrogen, wood, wind, solar, tidal, etc. Now we'll go to E. Here you have a fully charged cell of electromotive force, 6 volt, delivers a constant current of 5 amps for a time 0.24 hours. So here you have a time electromotive force, and you have the current. The cell is then recharged by a rectangular solar panel. The dimension, this is the area for the solar panel, 0.4 times 0.15 meter, at a place where a maximum intensity of light. So the maximum intensity, remember, we can calculate the intensity. It's power over area. Power in watt, area in meter square, watt, and this one in meter square. So the unit is watt per meter square. And power, since I have electricity, the power delivered, it will be the current times voltage. Okay, so calculate the minimum time if the efficiency always is intensity out over intensity and energy out over energy in, or power out over power in, or energy out over energy n. Okay, over En, or P out over Pn. Now first I have the power, which is I times the area. The intensity is 380. Cross-sectional area is 0.4. All of them, I don't need to convert any unit, except at time. We'll convert it later. Use it later. Okay, so 0.4 till 0.5. All the units are SI units, so I solve immediately since all the units are consistent. And this will give me 22.8 watt. Now we know energy or power is energy over time. So if I need the energy delivered or energy out, will be power times time. So energy out, energy delivered, or E out or E delivered, will be P out, or the power delivered times time. Power, it's current times voltage times time. And this will give me the value of the current is 6, the value of the voltage 6, and the current 5. So the current is 5, voltage 6. Time, you have 0.25 hour. Now 1 hour is 3,600 seconds, 60 times 60. So this value, you will get 27,000 joule. We said efficiency is P out over Pn, or energy out over energy n. So to find the P out or P delivered is efficiency times Pn. So P out here, the efficiency times Pn. Efficiency is 0.18 and Pn is 22.8. And this will be 4.10 watts. Now I need time. Time, it will be energy delivered divided by P delivered. So energy delivered, this is the value of the energy delivered. Here, this one, energy out, which is 27,000, and P out is 4.1. So T, let's do it here, to replace. So we know power, energy over time. Swap, I needed time. So T will be energy over power. Energy out, or energy delivered out. And this will be 27,000 divided by 4.1 will give us 6,000 585. You can round it to two significant figure, which is around 6,600 seconds. Okay, now the last section of the question, outline why research into solar cell technology is important to society. This you can search it. It doesn't produce greenhouse gases. It reduces the use of fossil fuel, etc. Okay, that's it. We'll continue the rest of the past paper exam, May 2022. Next videos, inshallah.